Day 8 of 365 was the first real data structure day of the track, and arrays were the right place to start. Arrays look simple, but a lot of DSA intuition is hidden inside them. The useful shift today was treating arrays as a memory layout choice instead of as default syntax. Once I started thinking about contiguous storage, fast indexing, and shifting cost, arrays immediately felt more interesting and much more important. The first big lesson was that arrays are powerful because of contiguous storage. Their elements sit in consecutive positions, which means index-based access can be computed directly from the base address and the offset. That is why reading ARR I is 01. The cost does not depend on whether the array has 10 items or 10 million. That predictable access pattern is the first major advantage of arrays and one of the reasons they show up everywhere. Another useful shift was separating access from modification. Traversal is naturally efficient because I can walk through the array in one predictable pass. That works well with caches and keeps the read pattern simple. But insertion and deletion are different when they happen in the middle. The expensive part is not adding or removing the value itself. The expensive part is shifting everything after it so the array stays contiguous. That makes arrays a great example of trade-offs. If I mostly need random access and sequential scans, arrays are excellent. If I expect lots of middle updates, the cost becomes much more visible. Day 8 made that trade-off feel concrete because it was easy to see how the structure itself creates the behavior. The array is not slow or fast in a general sense. It is strong at some operations and weak at others. The next useful shift was understanding static versus dynamic arrays more clearly. A static array has fixed size. A dynamic array can grow, usually by allocating a larger block and copying values when needed. That is why appending in a dynamic array feels cheap most of the time, but can occasionally trigger a more expensive resize. This was a nice connection back to amortized analysis from earlier in the week. Most appends are cheap, and the occasional expensive growth gets averaged out over time. That made dynamic arrays much less magical. Languages often hide the resize details, but the underlying trade-off is still there. Flexibility is useful, but growth is not free. There is still a resize strategy, a copy cost, and a memory behavior that matters when scale increases. That is exactly why array fundamentals are more important than they first sound. Another useful shift was seeing how many later data structure decisions arrays already prepare me for. Do I need fast index access? Will I mostly scan? Do I need frequent insertion and deletion in the middle? Is memory locality helpful here? Is the size fixed or will it grow? Those are not only array questions. They are the first version of the questions I will keep asking when stacks, queues, linked lists, hash maps, heaps, and trees show up later. This also matters outside interviews. Production code constantly uses array-like structures because predictable access and traversal are valuable. But production code also pays the cost when shifting or resizing happens in hot paths. Understanding array behavior early makes it easier to recognize when a simple list is the right tool and when the operations suggest a different structure entirely. Another thing Day 8 clarified was that the basic operations are not all equal. Lookup by index, scanning, updating a known index, inserting near the end, deleting from the middle, and growing beyond current capacity all have different costs. Treating all of that as just list manipulation misses the real lesson. Arrays are teaching me to ask what operation dominates and what behavior the structure rewards. So my main takeaway from Day 8 was that arrays are the first true trade-off structure in the track. Contiguous storage gives fast access and clean traversal. Shifting makes middle updates expensive. Dynamic growth adds flexibility, but not for free. If those trade-offs become automatic, later structures will make much more sense because they can be compared directly against the strengths and weaknesses arrays expose. That is what made today useful. Arrays stopped being default syntax and became design.